All right, guys, let's take a moment to discuss this idea of rate of change and specifically how it pertains to these kind of real-world modeling situations that we've been exploring recently. So for the first, let's imagine you as a city manager, and you need to keep close tabs on the population of your city because as your city gets larger and larger as the population grows, you're entitled to more money from the state and the federal government to pay for public services. I mean, this is public school teachers, policemen, firemen, building roads, repairing bridges, whatever it is. So it's really, really important. And so let's say in 1984, the population of your city, and we're going to call it UNork, very original, I know, was 4 million people. And I know this is kind of outlandish, but let's say it grew to 16 million people in 2008. I know, big city, but I chose those numbers so it'd be an interesting combination for a good discussion right now. So my question to you is, how fast was the city's population growing during this period? Or I really should have asked, on average, how fast was the city's population growing during this time period? So we can certainly approach this in a number of ways. We can make a table of values. We can even sketch a graph. Let's start by just sketching a quick graph. So of these two, we haven't really defined any variables yet, but I definitely think that time would be our independent variable and the population would be our dependent variable. So if we were to sketch just a rough graph here, I think on our horizontal axis we would have time, and on our vertical axis we would have our population, pop, if you will. So in the year, let's see, 1984, there were 4 million people. So this is going to be a rough sketch. So here's 1984, and here is 4 million people. And then in the year 2008, it had grown to 16. So there's 2008 as our time, and 16 million people as our population. And I'm going to do this as population in millions, just so I can write 14 and 16 instead of 14 million and 16 million. We can also make a quick table of values. So here we'll have the year, and here we'll have the population. And so we've got the year 1984, 4 million. And in 2008, we've got a population of 16 million. Okay, so we want to figure out, on average, how quickly is this population changing? So what we're really asking is, if we were to kind of sketch this graph, now we don't know, for instance, we don't know that this is exactly how the population is growing. The population could have grown very quickly and then kind of leveled out. It could have been pretty much the same population and then in the last few years gotten really large really quickly. And we're kind of answering question B right here, right? In a specific year, 1992, no idea how the population is growing. In 2005, we have no idea. All we can do now is find the average growth of population, the average rate of change. And we're really going to use the slope of this line connecting them to find that average rate of change. And then once we find that slope, we can even use it to create an equation. Check it out. So what we're really looking for is, now we haven't defined any variables, but let's call the year X, we'll call the population Y. We're really looking for our change in Y over our change in X. We want to know how much has the population grown and how long did that take to kind of find a per year population growth. And whenever we're asking for a rate of change, people also often want to know, per 1 year, how many miles per 1 hour, how many dollars are you getting paid per day, per 1 day. So we're looking for that kind of per something number here. Well, I think between 1984 and 2008, I think that our population grew by 12. I think our change in our population was, 16 minus 4 for a grand total of 12. And I think that our number of years, how long did that take? Well, that took, let's see, is that 24 years? Let's find out. Our change in X is, it's whatever we finished with, minus wherever we started, 1984, is definitely going to be 24, I believe. So in 24 years, the population grew by 12 million. That was our change in our years, right, from 1984 to 2008, and our change in the population from 4 to 16. Awesome. Now this is a ratio, but we can also simplify or reduce that ratio just down to 1/2. Or heck, you can even call it 0.5. I know we're going between fractions and decimals, but oh well. And this 0.5 means that, on average, every 1 year, the population goes up by 500,000 people. Right? That's the same thing as this 1/2 here. In 1 year, the population goes up by 1/2. You can also interpret this to mean that in 2 years, the population goes up by 1. Right? Just 2 halves is 1. And so we have now found the slope of that blue line that we kind of sketched on our graph. And we have found that average rate of change. And you could even use that to create an equation if you wanted. So for instance, if we defined our independent variable to be the years since 1984, let's call it X, and our dependent variable to be the population of this city in millions, and unoriginally let's call that Y, well then I think we can create an equation not so bad. We know that in 1984 there were 4 million people in the city, and we knew it grew at a rate of 1/2 or 0.5 million people per year. So I think we could just say, okay, yep, the equation would be Y equals, well, that starting number, 4 million, 4 million, plus that rate of change, 500,000 people per year, times the number of years. Not so bad at all. And using that equation, we could predict what the population would be in 2020. All we gotta say is, well, how many years after 1984 is 2020? Well, let's find out. 2020 minus 1984. This is going to tell us how many years have transpired. 36. 36. So all we got to do is substitute in a 36 for that variable right there, and we find that the population should be 1/2 of 36 is 18. So in those 36 years, not surprisingly, the population will grow by 18 million for a grand total of 22 million. And so that's the general strategy here, right? All we need to do to find that average rate of change is find the change in your dependent variable and divide that by the change in your independent variable. And that gives you the ratio of that rate of change, which will also be the slope of this line connecting those 2 points. Is that exactly how it's been growing through every year? No, we have no idea. It could have been going faster, could have been going slower, who knows? But this will be the average rate of change.